Hi everyone, my name is Tariq Hussain and I'm a certified Tableau professional with over 5 years of work experience in the field of business intelligence. My day job involves me solving various operational problems via data for a large investment bank. Over the years, I have tried to master the art of data analysis and visualization and now want to teach these skills to everyone. In this course, I'll teach you everything you need to learn about building quality dashboards in one of my favorite data visualization tools called Tableau. We will learn about the basic concepts of business intelligence. I'll teach you how to think about designing a dashboard, the layout and various features of Tableau, and finally, we will learn how to build an effective visualization. Tableau is one of the best, if not the best data visualization tool available in the market today. It is free to use, easy to learn, and can help you build some really powerful dashboards in a few quick and easy steps. This course is meant for absolute beginners who are new to the field of data visualization and requires no prior knowledge about working with Tableau. Here is a quick roadmap of the entire course. We will start by learning about what is business intelligence, then move on to learning about what is Tableau. I will then show you how to download and set up the free version of Tableau. I'll take you through its layout, show you how to connect to data. We will explore important concepts on designing a dashboard, understand what are the various types of charts and how to use them. We will then build your first chart, learn about creating parameters and calculated fields in Tableau. We will then put everything together and build our dashboard. And finally, close this course with your class project. You will have access to all the raw files in each step, so you can compare your workings as we progress through the course. As you complete this course, you will have the skill set required to design, build, and share quality data visualizations using Tableau on any dataset of your choice. Data visualization is a quick skill to learn and of great importance in today's world where we are surrounded by data. So go ahead and start this course and let your data journey begin. I'll see you on the other side. Thank you for choosing this course. Let's get started. Before we start learning about Tableau, let us first understand what is business intelligence. Business intelligence refers to the art of solving problems by leveraging the raw data generated by a business to create actionable insight. Every organization has several processes and functions that have to be run daily to help in the day-to-day functioning of that organization. Each of these functions generates some amount of data that can be used to derive insights into that business. Let's take an example of an e-commerce firm like Amazon. Amazon collects huge amounts of data whenever someone places an order on their platform. For the purpose of our example, we will simplify and assume that Amazon is only collecting 5 key data points. These are: what is the order, what product was ordered, where is the product required to be shipped, what price was the product sold at, and finally, who ordered that product. Just by taking these 5 data points and aggregating them across every order that Amazon receives, we can begin to answer few key questions like: how many orders do we get in a month? What product has the most demand? What is the highest selling product in any geographic location like New York? What is the average sales price of a certain product? And finally, how many orders does a customer generate over a given month? As you can see, just collecting these 5 data points helped us provide valuable information and insight into Amazon's business. It is this conversion of raw data into actionable and valuable insight is what business intelligence is all about. The main purpose behind all of this is to help support a data-driven decision making. As more businesses around the world go digital, we are collecting more data today than we ever did before. This has led to a huge demand for people who can convert this raw data into actionable insight. Needless to say, the demand for people with business intelligence skill is increasing. The field of business intelligence has several parts to it. These include storing raw data, extracting this data, analyzing data, and finally, visualizing and reporting this data. In this course, we will be focusing on building our skill set to visualize the data. I hope with this chapter, I was able to give you a general idea of what business intelligence is and how data visualization fits into all of this. The next chapter will give you a detailed introduction and overview of the data visualization tool we will be using today, and will also give you insight into how many such tools are available in the industry. I'll see you in the next chapter. Welcome to your next chapter. Before we start learning the tool, let me give you a brief on how Tableau started. My journey with Tableau started about 6 years ago when I started working at Goldman Sachs. It was not long after that I fell in love with just how simple yet powerful the tool was. Tableau is a Silicon Valley based company on a mission to help everyone see and understand data. They want to make visualizing data as easy as asking Siri or Alexa to play you a song. Before Tableau came along, visualizing data used to be really hard, especially for people with no software background. This all changed when 3 Stanford researchers got a US Department of Defense grant to build a tool that can easily navigate and analyze large-scale information. One of these researchers was a founding member of the award-winning animation studios Pixar. They combined their experiences and went on a mission to make data visualization as beautiful as a Pixar movie and as easy as a simple drag and drop. Not long after that, Tableau was born. Tableau works on a radical new invention called the VisQL. It stands for Visual Query Language and works for building visualizations similar to how SQL works to fetch data from databases. I will not go into too much detail about VisQL, but if you are interested in learning more about it, I have left a link in the description below. Tableau was recently sold to Salesforce for about $16 billion and is now completely owned and run by them. Besides Tableau, there are a plethora of other visualization tools available for use. Some of the famous ones are Power BI, which is an offering by Microsoft, ClickView, Zoom Data, and as you can see, so many more. Tableau remains an industry leader and one of the easiest tools to learn from this list. With this, let's dive right into learning Tableau. In the next chapter, I will show you how to download and install the free version of Tableau on your desktop. I'll see you in the next chapter. Welcome to your next chapter. In this chapter, we'll learn how to install Tableau on your desktop. Tableau comes in various versions, and the main ones are as follows: Tableau Desktop, Tableau Server, and finally Tableau Public. Tableau Desktop is the paid version of Tableau meant to be used by data visualization professionals. This version of Tableau has the ability to connect to various data sources ranging from various types of databases to simple Excel spreadsheets. This version also lets you save your work on your desktop. Tableau Server is also a paid version of Tableau but meant to be used by large-scale enterprises. This version gives you the ability for an organization to host its own version of Tableau within its company firewalls and assign out various licenses to its employees. Tableau Public is a free version of Tableau meant to be used by anyone who is interested in data visualization. Unlike Tableau, this version lets you connect to very few data sources and only allows you to save your work on the Tableau Public Cloud. You cannot save anything on your own desktop. Apart from these two limitations, every other feature in this version matches with the professional paid version of Tableau. Tableau Public is well suited for anyone who is just getting started and wants to learn data visualization in depth without paying for a full professional version of Tableau. Throughout this course, we'll be using and working on Tableau Public. Let me now show you how to download and install Tableau Public on your desktop. You may follow along with me as I take you through the required steps. Launch your web browser and go to the website public.tableau.com. This is the landing page for Tableau Public. Tableau Public is only available for Windows and Mac users. Key in your email address. For the purpose of this exercise, I'll key in a temporary address and click on Download the app. You will get a prompt to save your file on your desktop. Save the file on your desktop and let it download. Once your file has finished downloading, Launch the downloaded file and follow the instructions. Click on Install. Complete installation of Tableau should take about a few minutes. Once the installation is complete, you should launch Tableau. Upon launching, you will be greeted by the launch screen in Tableau. Wasn't that super easy? In the next chapter, I'll take you in detail through the user interface. I'll explain what each page is about and how you can navigate and make sense of every screen in Tableau. I hope you are excited to use Tableau. I'll see you in the next chapter. Welcome to your next chapter. In this chapter, we'll learn about Tableau's interface. Tableau has a lot of views and each of them serve a specific function. So follow along with me as I take you through every view and its associated function. We are currently on the launch screen. This is where you can connect to various sources of data, open your past Tableau workbooks, or even discover a few resources from Tableau's website. Let's try making a connection to a data source. Once you have made a successful connection to your data, you will be transported to the data prep screen. Here, you can make changes in your data source, you can split the data columns, rename some of the columns, or even do a few joins within your data. We'll explore these topics in detail later during this course. Clicking on this icon over here will create a Sheet tab just like in Excel. This is where we can build visualizations. Let's explore this tab a bit in detail. At the top, we have the menu toolbar. Here, you can change a lot of settings in Tableau, and it also contains some really powerful options. I recommend exploring this further once you have completed this course. Below this menu, there is a toolbar with various options like Save, Undo, Redo, etc. All these options are contextual to what is going on in our Sheet tab. For example, the Clear Sheet icon over here is grayed out right now as there's nothing in our Sheet tab. If we place a few objects in our sheet, you can see that the Clear Sheet icon is no longer grayed out. You should also note that Tableau doesn't have an automatic save feature, so you will have to save your work periodically. On the left, you can see the Data and Analytics panel. This is where you will find the columns from your data that we loaded earlier. Now in Tableau, each dataset is divided into a dimension and measure. We'll explore these two topics in detail in the next chapter as well. This panel will show you any calculated fields or parameters that you have created. I'll show you how to create your own calculated fields and parameters in Tableau in the subsequent chapters. The Analytics panel here contains a few quick pieces of analysis. For example, if you want to quickly add a total to your graph, you can just drag and drop them into your sheet view. Now let's pay attention to the right side of our view. This is the Show Me tab. This is one of the most important features of Tableau. Show Me allows you to create beautiful graphs based on the data you select. For example, if I select these two data points here, Show Me will automatically highlight the possible graphs that I can create from this particular data. Any other graph that cannot be created from the data will be grayed out. Hovering on a graph type will show you what all is required to create a particular graph. For example, if I hover on a heat map, I can see that I need one or more dimensions and one or two measures to create this heat map. You can use Show Me to try out different versions of your graph and explore all possible graph types that you can create with the selected data. Let's go ahead and clear this sheet. Finally, we have shells. Instead of using Show Me, you can create a visualization by just dragging and dropping the fields into your data pane. There's a column shelf, a row shelf, a pages shelf, a filter shelf, and a marks card. Each of these have their own purpose. Columns and rows help you create visualization, while a filter shelf will help you add filters to your dashboard to include or exclude certain data points from the visualization. I'll teach you how to use Filters tab in detail in the subsequent chapters in this course. The marks card is made up of several other shelves, each of which have fields placed on them and can be clicked on to edit their characteristics. Changing the features in a marks card will change what's happening in your visualization. This is one of the most powerful features of Tableau, and you will be spending most of your time here while building visualization. There can be multiple marks cards, each dealing with its own characteristic. For example, you can create one to add colors, one for size, one for tooltips, and so on. Clicking on this icon over here will create a dashboard view. The layout in the dashboard view changes a bit. Instead of the data pane on the left, we have the dashboard pane. This area will show you all the sheets that you have made so far and the ones that can be used to create a dashboard. There are other objects like images, text boxes that can be added to the dashboard. Finally, we have the sizing and preview options that help you design dashboards for various devices. I hope you enjoyed this walkthrough of Tableau user interface. In the next chapter, we'll learn how to connect and prep data in Tableau. I'll see you in the next chapter. Welcome to your next chapter. In this chapter, I'll take you through how to download the data we will be using to build visualizations in this course. I'll also show you how to connect your data in Tableau and the various features of Tableau when it comes to modifying your data. With this, let's get started. For the purpose of this course, I've already secured the dataset. You can download the file from the link in the description below. Once you have downloaded the data and launched Tableau, you should see this screen. As you will remember from the previous chapter, this is your launch screen. On the left, you will see various connectors in Tableau. Since our data is in Excel format, we'll go ahead and click on the Microsoft Excel connector. Browse the location of your data and select the appropriate file. Tableau will automatically load the data and take you to the data screen. Tableau has a really interesting feature called the data interpreter. Data interpreter works by automatically identifying the correct data type for each of your data columns. It can also clean your Excel sheets. Like in this example, our Excel has 3 rows which are completely empty. A data interpreter can fix all this without you doing it manually. Let's drag and drop this particular sheet. As you can see, we have 3 empty rows here. Let's click on Use Data Interpreter and see what happens. As you can see, the empty rows are gone and we are left with this clean table. Each column in Tableau is assigned a data type. There are mainly 5 types of data in Tableau. These are text or string, numbers, dates, Boolean, and finally geography, like names of cities, countries, etc. Let's go ahead and change some of the data types for each of these columns. The country names will be geography, country. The country code will be geography and country again. Region, we want to leave it as string. Year will be a number whole. And CO2 emissions will also be a number decimal. As you can see, Data Interpreter pretty much correctly interpreted all the data points and their data type. It also was able to clean the empty rows that we saw from the table earlier. On the data prep screen, you can also hide certain column names, rename them if you would like, or choose to split one column into multiple based on certain conditions. For example, I don't want this column here, so I'll click on the arrow and then click again on hide. Similarly, I want to rename this column, so I'll click on the arrow again and click on rename. Now I'll rename the field to whatever I want to. Finally, to split a column, I can click on the arrow again and either choose to auto split or do a custom split based on any condition that I may specify. Auto split will automatically detect the column split condition from all the values in this column. Under custom split, I can specify the condition for Tableau to split this column at. Once you're done prepping your data, you can move on to your first sheet. You will notice on the left pane, the columns from your data are divided into two parts, measures and dimensions. You will also notice that some columns are colored blue, whereas some are colored green. The blue indicates a discrete variable, while green indicates a continuous variable. Let's explore these concepts a bit in detail. Measures are quantitative values like numbers, whereas dimensions are qualitative values like names. Measures can be aggregated and we can perform all sorts of mathematics on them, whereas for dimensions we cannot aggregate them. Measures are used for plotting and giving values in your chart, while dimensions are used as column names in your chart. Finally, measures are grouped to the level of detail in your chart, while dimensions set the level of detail. Moving on to discrete versus continuous. Discrete and continuous are mathematical terms. Discrete refers to unique and distinct, while continuous refers to unbroken and whole. Discrete columns are represented in blue, while continuous columns are represented in green. Both measures and dimensions can be converted into either discrete or continuous variables in Tableau. Whether a column is defined as discrete or continuous will have an impact on how your chart looks like. For example, let's take a look at this chart. On the left, you can see quantity is defined as continuous. Hence, it's represented as a line chart. Whereas on the right, quantity is defined as discrete, and hence, it's represented as a bar chart. Tableau will automatically construct these charts based on the column classification as discrete or continuous. Let's go back to our Tableau screen. Finally, the last feature on our data prep screen is the join function. Let's look at this example in our Excel sheet. Let's say we wanted to combine the sheet CO2 kiloton with the data CO2 per capita for each country. The common column between both the sheet is country name. So we can certainly combine both the sheets on this particular variable. Let's try to replicate the same in Tableau. We already have the sheet CO2 kiloton in Tableau. To join this with CO2 per capita, we need to double click on CO2 kiloton sheet. This will open up the join screen. Now drag and drop CO2 per capita sheet onto the panel. Tableau will try to join the two sheets on the common column. In this case, it has joined the sheets on the column year. We do not want this. We want to join the tables on the column country name. Let's fix this. I will first select the country name on the left table and then select country name again for the right table. As you can see below, the tables are joined correctly and we have both CO2 kiloton as well as CO2 per capita on the tables together. This particular type of join is known as the inner join. It only keeps the actual joined columns from both the tables. Similarly, there are three other types of join as you can see here. A left join will keep all the columns from the left table and only add the columns from the right table that has a match. The reverse of this is called a right join. It will keep all the columns from the right table and only add the columns from the left table that has a match. A full outer join works as a union of two tables. It will keep all the columns from both the tables irrespective of whether they match or not. With this, we have come to the end of this chapter. I hope I was able to explain to you all the features of data prep screen in Tableau. In the next chapter, we will discuss in detail how we should think about building visualizations. The next chapter is a very important one in this course as it will teach you the right questions to ask before building a dashboard. I'll see you in the next chapter. Welcome to your next chapter. In this chapter, we'll learn about the building blocks of a good dashboard and learn about certain concepts that sets a great dashboard apart from a good one. In my personal view, this is the most important chapter throughout this course. You see, making a data visualization is easy. Making a good one is hard. And making a great one, well, that's where the concepts you will learn in this chapter will play an important role. I'll teach you how to ask the right questions before building a visualization. Not only these questions will help you create a great dashboard, they'll make your job to create one so much easier. With this, let's get started. Before you create a dashboard, you need to ask yourself 3 questions. What problem I am trying to solve? What questions should my dashboard answer? And finally, who is my target audience? The answer to each of these 3 very important questions will help you determine key things about your dashboard. For example, answer to the question, what problem I'm trying to solve, will help you determine the purpose of your dashboard. Your dashboard should only be aimed at solving that problem and nothing else. It is very easy to add more information than required to a dashboard, which ultimately leads to a clutter. And unless the purpose is clearly defined, more often than not, you'll end up losing track of why you started to build the dashboard in the first place. Similarly, answer to the question, what questions should my dashboard answer, will help you decide the most important questions that need to be asked to solve the problem that you are trying to solve with your dashboard. Once you have narrowed down to a few key questions, you should focus on building visualizations to only solve those questions and nothing else. This will help you stay focused and prevent your dashboard from having too many elements in it. Finally, the answer to the question, who is my target audience, will help you determine the level of detail you need to put in your dashboard. If you are creating a dashboard for a CEO of a company who is interested in visualizing sales across the country, then adding store level details is not necessary. You can summarize the sales per city or state and then visualize it across the country. Addressing these 3 questions before building any visualization is of utmost importance and will prevent you from making common mistakes while building your dashboard. A good dashboard also has a few other characteristics. A good dashboard is specific. It answers very specific questions and doesn't try to go into too much detail about things that are not required. A good dashboard has a purpose. Just by looking at the dashboard, it is evident as to why it is built and what problem it is trying to solve. A good dashboard is easy to read and navigate. It isn't too cluttered or has too many elements in it. A good dashboard should have a natural flow to it and is easy and intuitive to read as a book. Finally, a good dashboard knows its audience. It only provides the level of detail required by its audience and doesn't try to go into more depth than is necessary. Let me now show you a few examples of bad dashboards. You'll notice a common theme among these. These are either too cluttered, hard to read and understand, or are just hideous to look at. Just by looking at them, you'll not be able to make out as to why they were built and what is their purpose. Now let's look at a few examples of good dashboards. The common theme among these is they are clean, easy on the eyes, easy to read, have a natural flow to them, and just by looking at them, you can figure out their purpose. Most of these good dashboards are taken directly from Tableau's community website, where creators can share and host their dashboard for everyone to see. I hope now you have a clear sense of what sets a good dashboard apart from a bad one, and what should be your thought process before building a visualization. In the next chapter, we'll learn about various types of chart that exist and how to use them correctly to create maximum impact in your visualization. I'll see you in the next chapter. Welcome to your next chapter. In this chapter, you will learn about some of the most common chart types, their use cases, and when to use them for maximum impact in a visualization. There are many chart types that exist. I'll teach you about the 7 most common ones that you will encounter while building dashboards. These 7 charts should be sufficient to create any dashboard you require. With this, let's get started. The first chart type is a bar chart. Bar charts, are also known as column charts, are the most common of chart types. They are used to plot numerical values against your data point. You can use them to represent and compare data from highest to lowest or best to worst. Only use bar charts when you have a few variables to compare. Using a bar chart to compare 50 plus variables will make it redundant and create too much clutter in your dashboard. If you do have many data points to plot, consider plotting the top 10 or 15 in your data and grouping the rest of them as other. This way, you can plot your data in a bar chart without creating too much clutter. Next chart type is a line chart. Line charts are usually used to plot time series data. They work very well when you have a date dimension in your data and want to showcase how your data has moved across time. Stock price charts are a great example of a line chart. You should not use a line chart to represent data without any time dimension to it. Plotting a line chart without any time dimension will make it confusing and less intuitive to read. Next chart type is an area chart. Area charts also use time dimension to plot, but are used to showcase trends and change in percentage share of a total over a given period of time. For example, you can use an area chart to showcase how market share between Netflix and Amazon has changed over a given period of time. Do not use an area chart when you just want to compare change in share of total without any time dimension to it. Let's move on to a scatter plot. Scatter plots are used to visualize relationship and patterns between two numeric values. They are great to use when you just want to discover patterns and relationships in your data. Using scatter plots can also help you see if your data is correlated and can help you identify trends that may be hard to visualize with any other chart. Do not use a scatter plot when there is no relationship in your data. It will look random and will not be intuitive to read and understand. Next up is a heat map. Heat map also helps you identify relationship between two data points with a slight difference. They help you visualize the intensity of a relationship in your data. Use of color is an important part in a heat map, and the intensity of a color is used to indicate the intensity of a relationship. Just like scatter plots, do not use heat maps if you do not have any patterns in your data. Next are geographic maps. Geographic maps are a great way to visualize latitude and longitude data. For example, if you have sales data for each city in Canada and you want to visualize which city has the maximum sales, you can do that in a very intuitive manner with a geographic map. Cities with maximum sales can be colored darker compared to cities with minimum sales. Geographic maps help you easily convey area information. Obviously, you should not use geographic map when you have too little or no geographic data in your dataset. Finally, we have pie charts. Pie charts are the most tricky of all chart types. They are used to convey percentage share of a total, but more often than not, they are used incorrectly. Pie charts are also hard to read and not very intuitive. It is best to avoid using them and convey the same information with a bar chart. But if you do plan to use them, make sure that your chart is readable and easy to understand. It should also convey the percentage share details and should only have a few data points to it. With this, we come to the end of this chapter. I hope you were able to learn about the various common chart types that exist and when you should use them, but more importantly, when you should avoid using them. Most dashboards get too cluttered as they have been visualized using the wrong chart type. In the next chapter, I'll take you through building your first chart in Tableau. You have come a long way in this course and are ready to start using Tableau to its full potential. I'll see you in the next chapter. Welcome to your next chapter. In this chapter, we'll apply what we have learned so far. Our objective is to build our first chart in Tableau. By now, you should be familiar with our dataset. It contains CO2 emission data of various countries in the world. Let's see how we will build this first chart. Before building any dashboards, we should ask ourselves the three main questions. What problem I'm trying to solve? What questions should my dashboard answer? And finally, who is my target audience? Let's answer all these questions for our dataset. Answer to the question, what problem I'm trying to solve, will be that we want to gather insights into how CO2 emissions have changed over the last 50 years. For the question, what questions should my dashboard answer? The answer would be, our dashboard should be able to tell us what are the top countries contributing to CO2 emissions, how has CO2 emissions for a particular country increased over time, and finally, does income levels of a country impact its CO2 emissions? For the last question, who is my target audience? The answer would be, my target audience for this dashboard is all of you. Since I'm only creating this dashboard to show how Tableau is used, I don't need to go into too much detail about CO2 emissions for each country. Now that we have our questions ready, let's take a look at our data. We will now join all the three tables in our dataset and change the data type for a few columns. Let's first join all our tables together. We already have the CO2 kiloton table on the data prep screen. Double-clicking on the table will open the join screen. I will now drag and drop the CO2 per capita table on the join screen. I want an inner join on the column country name and year. Since year is already added, I'll go ahead and add country name. I also want some information from the table metadata countries. So I'll drag and drop that to the join screen as well. Tableau has automatically done an inner join on the column country code. This is exactly what we intended to do. Now since all our data is joined, let's focus on cleaning our dataset. At this stage, we will either rename, hide, or change data types for each column. Let's start with the country name on the left. Since I need this column and country code, I'll leave them as it is. I also need the column region and year. I would need the columns CO2 kiloton. Country name, country code, and year are a repeat of the previous columns. So I'll go ahead and hide these columns. I need the column CO2 per capita. I don't need country code since it's a repeat of the previous column. So I'll go ahead and hide this column as well. Similarly, I don't need region or the column table name. Finally, for the column income group, I'll go ahead and change the values of some of the variables in it. After renaming, you can see all the values are now changed. Since our data prep screen is done, we can create our first chart. To create visualizations, we will move on to sheet 1. For this visualization, we will answer the question, which country has contributed the highest CO2 emissions in the last 50 years? As you will remember from our chapter types of chart, a bar chart will be perfect for this visualization. To build a bar chart, drag and drop country name to the rows shelf. Since we want to visualize total carbon emissions, let's drag and drop CO2 kiloton field to the column shelf. As you can see, Tableau has automatically summed the field. To find out the top contributing countries, we need to sort this chart. You can perform a sort by clicking on the country name pill in the row shelf and then clicking on sort. This will open up the sort window. Since we want to know the highest contributing countries first, we will change the sort by to a field and change the sort order to descending. The field name will be CO2 kiloton and the aggregation will be a sum. This will sort the data with top contributing countries on the highest. There are a lot of countries displayed in this bar chart. Let's try to put a maximum of top 12 countries. To do this, drag and drop the country name column from the left to the filters shelf. As the name suggests, filters shelf lets you add filters to your visualization. We can either select the countries from this list, create a filter based on a wildcard search or on a condition, or display the top values. Since we want top 12, we will choose this option. Change the selection from none to by field and key in the value 12. The field will be CO2 kiloton and the aggregation will be sum. Click on apply and then click on OK. Our chart now has the top 12 countries by their carbon emissions. At this stage, we will add some formatting to our visualization. First, let's add a title to our chart. To do this, double-click on Sheet 1 and add the question for your visualization. You can even change the font type, font size, or the color. Click on Apply and then click on OK. Next, I want to change the y-axis of this chart. I want to make these country names left aligned. To do this, right-click on the country name and then click on Format. Under Alignment, I'll change the settings from Automatic to be left aligned. Finally, I want this chart to be more readable. To do this, I'll hide the x-axis and add values to the bar chart itself. To hide values, I will right-click on the x-axis and uncheck the option Show Header. Then, I will drag and drop the CO2 kiloton to the Labels field. I'll change the size of the font to be a little smaller so that it can accommodate everything. I'll make this even more readable by changing these numbers to millions. To do this, right-click on the Sum CO2 kiloton field and click on Format. Under the Numbers option, change this to Numbers Custom, Display Units to Millions. Since it's evident that these are country names, I will remove this country name header from here. Our visualization is now ready. It is evident, it is readable, and is neat. Creating a chart in Tableau was that easy. To create the next set of visualizations, I'll have to teach you what are calculated fields and parameters. The next chapters will teach you all about them in detail. I'll see you in the next chapter. Welcome to your next chapter. In this chapter, we'll learn how to create and use parameters in Tableau. Parameters are powerful tools in Tableau that allows you to let a user enter an input. Tableau then uses this input to create visualizations. Common examples are what-if calculations or letting a user change the level of detail in a visualization. You can think of parameters as placeholders for values in your visualization. A user, through a parameter, will be able to change these values and accordingly the visualization in the dashboard. For example, you may create a calculation in Tableau that returns true or false if the sales is greater than 100,000. Instead of keeping this value of 100,000 as constant, you can replace it with a parameter and allow the end user of the dashboard to change it to whatever value they would like. For our dashboard, we'll be using parameter to allow our audience to change between two measures, the CO2 kiloton and CO2 per capita. Let's go over to Tableau and see this with a live example. So right now, our visualization uses the field CO2 kiloton. We want to allow the user of the dashboard to switch the visualization between CO2 kiloton and CO2 per capita. We will accomplish this with the help of a parameter. To create a parameter, right-click on the left pane of your screen and then click on Create a Parameter. This will open up a new window. We will first give a name to this parameter. Let's call it Choose a Metric. We can now start to fill in other details for this parameter. Just like the columns in our data have a type, parameters need a data type as well. For our parameter, we will select the data type as integer, and under allowable values, we will change from all to a list. Since we only want to provide two options, we will key in two values, 1 and 2. Now to make this part more readable for our audience, we will change the display as from 1 and 2 to actually mean something. Change value of 1 to CO2 kiloton. And value of 2 to CO2 per capita. Then click on OK. You will notice at the bottom left of the screen, a new field with the heading Parameters is now available. Right-click on Choose a Metric and then click on Show Parameter. This will make the parameter selection visible on the top right of our visualization. As you can see, it has two options right now, CO2 kiloton and CO2 per capita. Switching between these two options wouldn't really do much, as the parameter is not really assigned to any value. To assign this parameter, we'll have to create a calculated field and use that in our visualization. Let me first explain to you what calculated fields are in Tableau and how they are used. We will now learn about calculated fields. Calculated fields allow you to create new data in Tableau from the data that already exists in your data source. Creating calculated fields basically means creating new columns in your data source. You can use calculated fields to do a lot of data manipulation, ranging from simple data aggregation to more complex level of detail calculations. Calculated fields are building blocks in Tableau, and you'll be using them in almost every visualization you make. You should use calculated fields whenever you want to manipulate your dataset. This can be as simple as adding or subtracting two columns to create a new third column. Let's see how we'll be using calculated fields in Tableau for the purpose of our dashboard. To create a calculated field in Tableau, right-click on the left pane and then click on Create Calculated Field. This will open up the Calculated Field window in Tableau. We will begin by assigning a name to this calculation. Since this calculation will help us use the parameter we created earlier, let's name this as Metric Choice. Towards the right, you can see this arrow. Clicking on it will open up all the functions you can use to create a calculation. If you ever feel you need help in creating a calculation or do not know the right way to create one, you should look here. Since I have to use the parameter, I want to create an if-else conditional calculation. I will type if choose a metric equals to 1, then CO2 kiloton, else if choose a metric equals to 2, then CO2 per capita. I'll close this statement with the end keyword. Click on Apply and then click on OK. We now have the calculation as a new variable. Our current chart uses CO2 kiloton. Let's replace that with this calculation. To do that, I'll right click on CO2 kiloton and then click on Replace References. I will then select Metric Choice as the new variable to replace this with. Click on OK. Our visualization is now updated with the new variable. Now let's see if our parameter is working. As you can see, just by changing the values in the parameter, I can change the values in the visualization. With this, we have come to the end of this chapter. I hope I was able to explain to you what are parameters and calculated fields in Tableau. In the next chapter, we'll be designing all the other charts required for our dashboard. I'll see you in the next chapter. Welcome to your next chapter. In this chapter, we'll be designing visualizations for the rest of the questions that we noted down earlier. I will click on the new sheet icon to create a new sheet in Tableau. Let's build the chart for our next question. How has CO2 emissions for a particular country increased over time? If you remember from the chapter, Types of Charts, line charts are the most ideal to represent changes over a given time period. Since our question has a time element to it, we will be using a line chart to build this visualization. To answer our question, we need these data columns. For CO2 emissions, we need the column metric choice as it is tied to our parameter that we built earlier in the previous chapter. For country names, we need the column country name, and for time, we need the column year. Now that we have identified our columns, let's drag and drop them onto the sheet. We will first drag and drop the column year to the column shelf. Then we will drag and drop metrics choice to the rows shelf. Tableau has automatically created a line chart for us, but we still need to add country names to this visualization. Since there are over 160 countries, we cannot add them to color or show 160 lines on our chart. That will defeat the purpose and make it not at all intuitive or even easy to read. Let me show you how the visualization may look like if you add all 160 countries to it. You clearly cannot make any sense from this chart. So let's undo this. To undo something in Tableau, go over to the toolbar and click on the undo option. Now let's add country name to this chart while preserving its readability. To achieve this, I will drag and drop the country name field to the filters shelf. This will open up the filters window. Select any single country you want and then click on apply. And click on OK. Our chart now shows us data only for the single selected country. But we also want to let our users be able to filter to any other country they want to. So let's give them that functionality as well. Right click on the country name pill in the filter shelf and then click on show filter. You will notice a filter with all the country names is added to the right side of our screen. Let's format and customize this filter to make it more readable. Click on the arrow next to the country name. This will show you the filters customization panel. We have multiple options in this panel. We can either choose our filter to be a single value or multiple value. I also have options to choose the filter between a list, a drop-down, or a custom list. Since we have over 160 countries and we want to make our filters more readable, I will choose the option as multiple values drop-down. Our filter looks a lot cleaner now. There are multiple other options available in the filter customization panel. You can either format the filter, customize it to include apply button, change it to include only relevant values, or change the filter to either include or exclude values. I will encourage you to spend time and try all these various options when you do the class exercise. I will go ahead right now and add the apply option. Using this will make Tableau wait for the user to hit on apply before changing the contents of the chart. Let's see if our filter is working. I will uncheck this country and select Austria. Then click on apply. And as you can see, the values in the chart changed. Now let's make this chart more readable. We will start by changing the sheet name to the question that this chart answers. Click on apply and then click on OK. I will then hide the y-axis and add labels to this visualization. To do this, right click on the y-axis and uncheck show header. Drag and drop metric choice to the labels field. Since we are only interested in how values of emissions have changed over the years and not the value of each year, we will hide all these values and instead change the visualization to only include the minimum and the maximum value. To do this, click on label and under the marks to label, change it from all to min and max. Finally, it's evident that these values are years. So I'll remove the word year from this visualization. To do this, right click and then click on Edit Access. This will open up a new window. Under Title, I will remove the year and then close this window. Our visualization is now ready. Let's rename this sheet to what it actually represents. Let's move on to our next question. Do income levels of a country impact its carbon emissions? I will click on a new sheet and identify the columns that are required to build this visualization. For income levels, I need the column Income Group, and for carbon emissions, I need the column Metric Choice. Since we want to build a compare between income groups and their share of carbon emissions, we can use a couple of charts here. Recall from our earlier chapter, types of charts. To show shares of a total without time element to them, we either use a pie chart or a heat map. Since I do not like using pie charts, I will opt for using a heat map instead. Also recall that if we had to show change in share across time, we would have used an area chart here. To build a heat map, first drag and drop the income group onto the text field. This will give us various income groups that exist in our dataset. We now have to add the shares of total among them. To accomplish that, we will first drag and drop the column Metric Choice to the size shelf. This will divide the chart according to how much carbon emissions these group of countries represent. Notice how all of them are of the same color. We can't tell right now if lower middle income is as big as high income non-OECD countries. We need to make this chart more readable. We can do this by adding color and text to this chart. Let's first add colors by dragging and dropping Metric Choice to the color shelf. Now let's add percentage of share that these squares represent. Drag and drop Metric Choice again to the label shelf. This will give us the sum of the total CO2 emissions in that square. We need to change this to a percentage of total. To do this, click on Metric Choice and then click on Quick Table Calculation. Under Quick Table Calculation, select % of total. This will add percentage of total to the chart. Let's get rid of the decimal places from these values. To do this, right click on Metric Choice and then click on Format. Under Numbers, click on Percentage and reduce the decimal places from 2 to 0. Finally, let's add the question for this visualization as well. Double click on the heading which says Sheet 3 and type in the question. Click on Apply and then click on OK. Finally, let's rename the sheet to what it actually represents. Since we have country and geographic data, let's create one more chart using this data. Add a new sheet and then click on Country Name and Metric Choice. Hover over to Show Me and then select the geographic map from the middle. Tableau will automatically create a world map for us. Each country is highlighted based on the values from the column Metric Choice. Hovering on a country will show you the values for that particular country. Let's now change the background of this map from dark to light. Head to the Map option in your toolbar and under Background Maps, change the setting from dark to light. We do not need a chart name for this, so right click on Sheet 4 and click on Hide Title. Finally, let's rename this sheet to what it actually represents. We now have all our visualizations ready. In the next chapter, I'll show you how to combine all these into a dashboard. We will be learning about various features of a dashboard and how to create one in such a manner that combines all these sheets together. Interacting in one sheet will automatically change the values in the other. I'll see you in the next chapter. Welcome to your next chapter. In this chapter, we'll be combining all the visualizations we made earlier to build a single dashboard. Let's begin where we left off in the previous chapter. Instead of creating a new sheet now, we will click on this icon to create a new dashboard. Before designing any dashboard, we need to decide its size and layout. Tableau offers multiple layouts for various devices like phones, iPads, desktops, etc. You can also set your own custom layout and size. Let's change our layout to a custom size so I can fill my entire screen. You can change the layout as per your own requirements. I will change the width to 1600 and height to 870. This will cover up my entire screen. Now that our layout is set, let's start by adding our visualizations to the dashboard. Click on the world map sheet in the left pane and drag it onto your dashboard. The sheet will automatically cover the entire space that's available to it. Let's add the rest of the sheets as well to this dashboard before we make any further adjustments. I will drag and drop the remaining sheets to where I want to place them on my dashboard. As you saw, Tableau was automatically adjusting the other visualizations as I kept on adding more to this dashboard. We now have all our visualizations in one place. It's time to format this dashboard. You can adjust the size of any visualization by changing its width and height. To change the width or height of the chart, hover to its edge and just drag. Now let's place the filter and legends from the right pane onto our dashboard. Currently, these are fixed towards the right pane. We will need to change them from fixed to floating. Click on the filter or legend and then click on the arrow. Finally, click on floating. This will change the filter from a fixed position to a floating. You can now drag these to wherever you want on your dashboard. We will first place the legend at the bottom of the world map. Let's place the parameter at the top left corner of our dashboard. The reason I chose the parameter to be placed at the top left is that this is the prime real estate of your dashboard. Humans are naturally aligned to read from top left corner of the screen. So make sure you place your most important elements and charts of your dashboard here. I do not plan to use the filter for country name, so I'll just remove it from my dashboard. Instead of country name, we'll make the charts itself clickable and use them as a filter. Let's see how we do that. Click on the chart, top countries by CO2 emission, and then click on this icon, which represents a filter. Clicking on this icon will make your chart interactable. Now, whenever your user will click on any country name in this chart, it will automatically be used as a filter for other charts as well. Let's try this out. I will click on this country, and as you can see, all the other charts are updated with data from this particular country. Clicking on the country name again will make the charts to go back to their default view. Using chart as a filter adds a level of interactivity in your visualization and makes it more engaging. Use this functionality whenever you want the users to select something from the chart itself. We will go ahead and add this functionality to both world map as well as the income group charts. I will also go ahead and remove this unknown from my world map. It's time now for some formatting. First, let's make all these charts to occupy the entire space available to them. To do this, we'll click on the chart and then click on the arrow. Under Fit, change it from Standard to Entire View. This will let the chart occupy the entire space that's available to it. Now let's align the headings for each of our chart. Double click on the heading and then format it. Since it's obvious that this is a world map, we will get rid of this particular title. Right click on the world map and then click on Hide Title. We will also remove the title from our legend as it is implied. Finally, let's add a title to our dashboard. This is where we will utilize the objects that are available to us. There are several of these objects ranging from text to images. We will select the text object and drag and drop them at the top of our dashboard. This will open up the title screen. Key in the title as per your choice. I will call this World CO2 Emissions and format it accordingly. Let's also add some background color to this title. To add background color, click on the title once and then click on Layout. Under background color, select the color of your choice. Finally, let's rename our dashboard tab in Tableau from Dashboard 1 to World CO2 Emissions. Our dashboard is now complete. Let's use this and see how every visualization behaves. As you can see, the dashboard is highly interactable, readable, and gives clear direction for each and every question. With this, we have come to the end of this chapter. There is so much more that you can do with this dashboard and add so many more details to it. In the next chapter, I'll explain your class project and share some final thoughts before we wrap up this class. I'll see you in the next chapter. Welcome to your last chapter. In this chapter, I'll share your class project along with a few final thoughts before we wrap up. Let's start with your class project first. So your class project is to recreate a dashboard based on the same data I have used throughout this course. I want you to come up with a different set of questions to explore and build visualizations on. You can either choose to focus on a single country or a group of countries. Try exploring other chart types and what you can do with them. This will help you to apply what you have already learned throughout this course. You may refer to the workbooks I have shared and explore various other features of Tableau. Be creative and add your own touch to the dashboard. Once you're done building your dashboard, you can upload it to the Tableau public gallery and share the link. I will personally provide feedback on every submission. I also want to provide you with a path to continue building on your visualization skills. After this course and the class project, you should consider following these next set of learnings. All of them will cost you very little time and will really help you to further build upon your skills. The first one is to sign up for Viz of the Day. It is a daily selection of a really cool dashboard from Tableau Gallery delivered to your email address. Just exploring one dashboard a day will help you understand what others are doing with Tableau and will help to build your creative skills. Next up is exploring Tableau's public gallery. Every day, hundreds of dashboards are added to the gallery by people from all over the world on various topics. You can draw inspiration from these and even download them to learn how they were built. Finally, explore and sign up for Tableau certifications. I will leave a link to the Tableau certification page somewhere on the screen. These certifications are a really good way to formalize your skills. Most of what you have learned in this course is already part of the first level certification, and with a little practice, you should be able to clear the first certification. All of this will help to further advance your skills and reap long-term benefits. Before we wrap up, I want to congratulate all of you for coming this far and completing this course. If you found this course helpful, please do follow me and leave me feedback. It really helps me out and will encourage me to continue building more such courses. I will leave you with this quote: do something today so your future self will thank you. Learn the skills now so you can continue to reap benefits of your hard work in future. Thank you so much once again, and remember to never stop learning.